Welcome back. In this video, I'm gonna discuss about this worksheet entitled Scientific Notation. Well, the idea of scientific notation is it helps scientists, or maybe just like us, to express very large and very small quantities. So, what is a scientific notation? Let us make an example. Well, we can have this number, shall we say, 2.1, 2.1 times 10 to the 3. This is a scientific notation. This is one way of expressing a number. And what are the parts? So here, according to here, we have the number. There's an exponent here. Exponent n indicates here is 3, and the base here a, and the number a here is the 2.1. And how is this really? What is this? How is this written in conventional? What is its equivalent to in conventional number notation? The way we normally write numbers. Well, this simply means that 2.1 times 10 to the 3 simply means that we multiply 2.1 by, we multiply it by 10 to the 3. And what is 10 to the 3? It's 10 times 10 times 10. Well, at first it's awkward. I mean, will it be difficult to write that because we still need to multiply this 3 times? 10 to the 3 means 10 times 10 times 10. But actually it's not, because base 10, if you raise this to an exponent, you will just count the zeros. 10 to the 3 simply means that it's 1 followed by 3 zeros. So it's an interesting, and that's what makes base 10 very special. If you raise it to an exponent or to a power, you will just be counting zeros. So in this case, it will just be 2.1 times 1000, or basically we just move the decimal place 3 steps to the right. 2.1 times 1000. So the decimal is here. 1, 2, 3, and now we got 2100. And actually we don't need to do this step. We can just, if you express this number now, 2.1 times 10 to the 3, to the conventional way of writing numbers, you just need to move the decimal place here directly 3 steps to the right. Okay, so it will be the same thing here. 1, 2, 3, or it will just be 2100. Again, this is how we write it. The decimal is here initially to 1, 2, 3. So that's 2100. Okay, now how about what if we have a negative exponent? Because this is when the exponent is positive, is the quantity is like a big number, like bigger than 1, like 1,000, a million, 100,000. But what if we have a negative exponent? What's the purpose of this? So what if in this case we have, instead of to the 3, positive 3, what if we have like 2.1 times 10 to the negative 3? What does this mean? Well, if we recall our algebra, 10 to the negative 3 simply means 1 over 10 to the 3. When we want to make the exponent positive, we just get the reciprocal, or flip this number here. And again, 10 to the 3 is just 10 times 10 times 10, or 1 over 1000 here. But it's easy in the base 10, because we just when we say we divide by 1000, it simply means that we move the decimal 3 steps to the right. So 1 over 1000 means, okay, like this, 1 over 1000. In this case, what does 10 to the negative 3 means? The 1, this is what we do. 1, the decimal of a whole number is on the right side. It's like there's a virtual decimal number here, decimal point. We just move this one. 1, 2, 3. So we put zeros where there are blanks. So this is like, we count again. The decimal is here supposed to be, and we move 3 places to the left. 1, 2, 3. So 10 to the negative 3 is just 1 over 1000. So in this case, it will be 2.1 times this one, 0.001, or Now, when we do this, this will also make us move the decimal 3 steps to the left. Okay, so instead of 2.1 here, I'll just put some zeros here. We'll move the decimal 1, 2, 3. So 2.1 is just equivalent to 0.0021. Or when we directly just look at the scientific notation, when the exponent is -3, we just simply move the decimal 3 steps to the left. So in that case, it will be 1, 2, 3. So you put zeros in there. So 2.1 times 10 to the -3 is just 0.0021. Of course, it's more formal to write this with zeros in the beginning of a decimal. 0.0021. It's just, they are equivalent, but it's better to write with a zero first than a decimal. So that's it. I remember that when the exponent is positive, we move the decimal place to the right, and when the exponent is negative, we move the decimal place to the left. Point, I mean. So here, let's have a little example. For example, this one, 123 million. And how do we write this in scientific notation? Well, it could be, you could write it this way. There are many ways. For example, here, according to here, he wrote it this way. First, move the decimal place. The decimal place is supposed to be initially here. It's a whole number. If you don't see a decimal, that means the decimal is at the end. And if you move 3 places here, like 1, 2, 3, 4, 6, 5, 6, you will supposed to get this. Why 6? Okay, I think something's wrong here. Supposed to be this 1 million here. Okay. It will mean 123 times 1 million. Or you can write it like 123 times 10 to the 6 if you just stop there. But when we do scientific notation, as what we have agreed on, the number here must supposed to be between 1 and 10, and 123 exceeds 10. 1 and 9. 123 exceeds 10 already, so we don't stop here, but we stop until we get a single digit to the left of our decimal point. What does that mean? So we continue counting. This is already 6, 7, 8. Okay, so we move the decimal place 8 times towards the left. And when we do that, that means our exponent is a positive 8. So it will be 1.23 times 10 to the 8. It's somehow the reverse of starting from the scientific notation going to the conventional way of writing numbers. In here, just recall that if you are in the conventional way of writing numbers, and when you move the numbers to the decimal to the left, it means that your exponent must be a positive number. So just remember this. If you are confused at times, because a common mistake here is that student will just then put this as 1.23 times 10 to the -8. So these are just the very common ones. So if you fall into this trap, you are now confused whether the exponent is a positive 8 or a -8, what shall you do? Just remember that this must not be correct. Why? Because you always remember that if the exponent is a negative number, that means that the actual number is a small one. And if the exponent is a positive number, that means that the actual number in conventional writing is a big one. So in this case, we know that 123 million, if it's money, that will be big, right? Now, it means that the exponent, if it's written in scientific notation, supposed to be a positive number. So 1.23 times 10 to the 8. How about this one now? A small one, 0.0005. So the best way of writing this in scientific notation is simply to move a decimal place. Okay, we'll move a decimal place. 0.005. we'll move the decimal place until such time that we have a single digit number to the left of the decimal. Okay, so how shall we do that? 1, 2, 3. Okay, we stop here so that we'll have a number now here, 5. 5 times 10 to the, so it will now be 5 times 10 to the. Now if you are confused again whether to put a positive 3 or negative 3, you should not be, because when you put the number here, 5 times 10 to the 3, always remember that, oh, why is this positive? 0.005 is a small number. So always remember that if you move decimal to the right, in converting to scientific notation, that means it must be a negative exponent. So a good way to check is that looking at the number, if it's small, remember it must be supposed to be. So it's what? It's a good way to do that in your final answer. So again here, if you move decimal place towards the left, how many times? That means an exponent is positive. Here, the same way, it will be negative exponent. So let's try to do some exercises. Okay, here I modified some of the problems in the exercises. We will just be doing these 4 so that you can do the rest on your own in the worksheet. Now, we are asked here to express this number in standard scientific notation form. Note that we are to convert this into standard scientific notation form. So for this one, 0.00036, well, again, we need to move the decimal place so that we will get a number 1 digit to the left. That's the standard way of writing. So the number to the left of decimal must be 1 digit number, non-zero number, of course. So here we'll start to move 1, 2, 3, 4, 5. We end here because now we get a 3 before a decimal. So it will just be 3.6. Now the hard part most of the time will be on what shall we put. How many steps do we take? 1, 2, 3, 4, 5. It's 5. So the idea here, shall we put a positive 5 or negative 5? Note that if we are moving the decimal to the right, the exponent are supposed to decrease by 5. So it's minus 5. Okay? Which makes sense because this is a small number. So the exponent must be negative 5. However, it may not be that obvious. For example, if we have 23 times 10 to the 5. If you ask me, what shall we do with this? Well, this is already in scientific notation. As we can see, there's a 10 to the 5. This is not the conventional way of writing numbers. But as you can see, this is not standard scientific notation because the number here is not between 1 and 10. I mean 1 and 9. So what shall we do? The decimal place here can be thought of, it's located somewhere here at the end of the whole number. Now our goal is to move a decimal so that there's only one number to the left of the decimal point. So what shall we do? Well, we do it like this. I mean, we move 1 step towards the left. Okay? So if we do that, the number now will be 2.3 times 10 to the, and we're moving towards the left. It means on 1 step, so it will be negative 1. I mean positive 1, right? Because it is, as you can see, this number is bigger than, so if we move towards the left, the exponent will be positive. But this is not correct, okay? Because the number here already has what? An exponent 5. It simply means that when we do that, when we move this number towards the decimal towards the left, we just add the exponent now with 1. So 5 plus 1 is 6, okay? Which makes sense supposed to be, okay? Because if you are really confused so meaning if we move towards the left, we add the exponent 1 in this case. So if you are confused, why is that so? You can think of it, 23 times 10 to the 5 means there's what, 5 zeros after the number. 1, 2, 3, 4, 5, okay? You can do it like this also. I mean, if you are really confused, then why not? So here, the decimal is here. Now we convert to scientific notation, the standard one. 1, 2, 3, 4, 5, 6, okay? So 23 times 10 to the 5 is the same as 2.3 times 10 to the 6. Similarly here, 0.0023 times 10 to the negative 3 This is not the standard way of writing because the exponent here is what is the base here is not between 1 and 9. So what shall we do? Well, we just move the decimal place 1, 2, 3 until we get a number that is one digit towards in the left. So it will be 2.3. But what will be the exponent? Since we are moving a decimal towards the right, in this case decimal point towards the right, that means that the exponent is supposed to be negative, right? 1, 2, 3, 3 steps. But since there's a negative 3 here already, it means that we make it more negative, meaning we subtract 3 from it. Negative 3 minus 3 is negative 6. Okay, so this will now be 2.3 times 10 to the negative 6. Again, we can just convert this to the standard, first in the conventional method, 0.0023 times 10 to the negative 3 means we move the decimal place 3 steps to the left, 1, 2, 3. So it means it's what? It's 0.00000023. Now, if you want to convert the standard scientific notation, we can just move it, the decimal point back, 1, 2, 3, 4, 5, 6. So here, you will get 2.3 times 10 to the negative 6. Yeah, it's confusing at first, but practice makes perfect. Just do some more practice. I hope you get something out of this session. Thank you.